In this video, I want to have a look at vectors. So before we start working with vectors and seeing how they can help us solve problems, there's some definitions and some notation that we need to introduce. So the first thing is just what is a vector? So a vector describes a shift in position from a starting position to an end position. So a vector has both magnitude, which is size or length, and it also has direction. So from a starting position, it's telling us how far it's going and in what direction. So for example, acceleration, force, and displacement are all examples of vectors. Now, to write a vector, there's lots of different notations. The two most common if you're handwriting are a letter, for example, V, with a little squiggly line under it. Some people, when they're writing, do a straight line instead, just because it's a little bit easier, but this is the most common notation. We can also write a V with an arrow going across the top. Or if you're reading it in a textbook, sometimes you'll see it written in bold, which obviously isn't practical to do when we're handwriting. We can also represent a vector using two letters rather than just one. So a vector can be represented by an arrow or a directed line segment. So it starts at A and it's moving in this direction to B. So the length of the arrow shows us its magnitude and the arrow head shows us which direction it's going. If we had a vector like this, we could also call it AB, and we draw the arrow across the top. Now, the order of the letters does matter. It's going from A to B. If it was going the other direction, if the arrowhead was on this end, not that one, then our vector would be BA with the arrow across it. Now we say that two vectors are equal if they have the same magnitude and direction, regardless of where they've been shifted around that plane. So for example here, all three of those vectors, all three of the arrows are exactly the same length and they're pointing in that same direction. So we could write that vector AB is equal to vector PQ, which is also equal to vector EF. Now if we have a vector A, then we say that the magnitude or the length of that vector is given by the absolute value of A. Now, like we looked at when we introduced this notation just before, if we write a vector AB, then the vector opposite that would be the same length but moving in the opposite direction. So we'd write that as vector BA. If we use our other notation, then the vector opposite A is negative A because we're just switching that direction around. We say that two vectors are parallel if they have the same or the opposite direction. So for example, if we have this one here, if we had one going in exactly the same direction, assuming that I could draw them perfectly, then they would be parallel. If we had one going in exactly the opposite direction, that's still parallel even though it's moving the other way. And the last thing we want to have a look at is what's called the zero vector. So the zero vector has a magnitude of 0, so a length of 0, and because of that, its direction is undefined. So the zero vector is just a point. It doesn't really have, well, it has a magnitude of 0, and it doesn't have direction. That's why it's undefined. We write the zero vector as a 0 rather than a letter. So the zero vector is its own opposite. We said that the opposites were, if we had a vector A, then the opposite was negative A. And the only way that can happen is if that vector is the zero vector. So being its own opposite, the zero vector is the only vector that will do that. Despite the fact that it has no direction, the zero vector is defined as being parallel to itself and every other vector. All right, so that's an introduction to the notation and some definitions we need to have a bit of a closer look at vectors.